This video introduces you to a software protection called control flow tagging. About the security requirements, the purpose of this protection is to control the code execution integrity. The protection enables to tag some portion of code called gates. Thanks to these gates, some dependencies can be set in the code. By setting gates here and there in the binary code, it can be enforced that some gates have been passed before running sensitive code. With such dependency mechanism, it prevents the attacker to jump directly to some part of the code. For example, if he wants to bypass some control. Otherwise, the protection detects the control flow has been tampered with. To enable this protection of the flow of application execution, some gates are statically inserted in the binary code of the application. A gate is associated with a portion of the binary code. In practice, it's a basic block. And a gate is implemented as a counter that counts how many times the execution flow passes the associated gate. This is very similar to the technique used with coverage tools when code is being validated through test campaign. The verifier part of the protection checks the gate execution through a logical expression. Let's see this on a diagram. Without the protection, some checking code is executed before running sensitive code, some critical code, let's say. The protection aims at detecting the attacker has directly jumped to this sensitive code and bypassing the checking process. With the control flow tagging protection, a gate is set in the checking process and verifier code is inserted before the sensitive operation, the sensitive code. And the verifier can adjust the reaction according to the strategy. About the scope of the protection, control flow tagging detects a tampered execution flow, but it do not react. And it needs to be used with another, to be combined with another protection called reaction mechanism, and there is a video that describes this other protection. Let's say in practice how it works on the demo. Demo is very simple. It's a user authentication through username password that is checked in a function, and if successful, secret data, that is a secret key, is displayed. And for this, we set two gates, one gate to check the username, one gate to check the password. And before showing the secret data, the secret key, there is a logical expression that checks that control has passed through the gates. Then there is a logical expression that is evaluated at that time. Let's see this on the code. This is the main of this simple control flow tagging test. Here we have the code where the user enters his username, password. Here the function that control the password is valid. And here, if valid, the resource is displayed. For the purpose of this test, the resource is just a key. Value is here that is displayed in to the console. Let's see the code of the check. Here we have two gates. We have set a gate here when the username is controlled, and another gate a bit later here when the password is controlled. These two gates has to be passed successfully, otherwise we don't want to enter in the show key part, the show key function. Here we have a logical expression that controls this. We want to be sure that counter 1 and counter 2 have the same value and that we have done the control at least one time. Otherwise, the simplest reaction policy is applied here that just exit the program. Then let's see this in practice. I will just icon this. Here we have two Android consoles. The one on the left hand will be the one where we'll run the sample, the application. It runs directly on an Android device. And to enable this, we have to be rooted. This is why you see the root on the left. The console on the right will be the one of the attacker, when the attacker will send a signal to the process running the application. First, let's run on the left the application without protection and without attack to see how it behaves. Username has to be entered, admin, and then the secret key is displayed. This is the expected behavior. Then let's run it again, but this time we will send, then first I have to retrieve the PID of the process. In this case, it's 5318. I have to send a signal, 5318. Then what will be the effect? The effect is that a signal will be sent to the process, then to the check function. The check will be bypassed, and then the secret key would be displayed, even if username and password are not entered. Let's see how it behaves. Done. Then username and password has been bypassed, and there's no value, and the attacker is very happy because he can access the critical resource, in this case, the secret key. Now we're going to run it, the sample with the protection. First, let's clear this to make it less confusing. Then on the left, I will run same the protection, the sample with protection. And before entering the username, I will send a signal. Then in this case, it's 2. Then what will the effect? The signal will be received by check. Then means the 2 gates, the one that controls the username and the password, won't be passed, that the counter won't be incremented. Then when checked, it means that the logical expression would be evaluated to false. Then the protection will call an exception and the program will exit. Let's see, without displaying the secret key. Yes, done. You can see here that nothing, the secret key has not been displayed because of the code of the exception sent by the reaction here. This concludes the video on control flow tagging. I will invite you to check the video on reaction mechanism, software time bombs, that will elaborate more on the reaction itself. The Aspire project has received funding from the EU7 Framework Program under grant agreement number 609734.